Hi everybody, my name is Eugene Royzengurt and I want to take a few minutes and talk to you guys about model analysis. More specifically about model analysis when it pertains to digital dentures. So I've been working with a program called 3Shape and trying to fabricate digital dentures. And you can also do the same thing with ExoCAD and some other programs. But I work with VITA on utilizing their Vigo tooth concept, which is kind of an interesting thing. They've redesigned their tooth molds to be specifically used for digital dentures. So there's no undercuts on the basal surface, and they have a slightly lower profiles, which makes it easier to work in situations where you have not a lot of room. So when you're starting to design digital dentures, in this case I have a full upper, full lower, one of the first things the program asks you to do is to identify some landmarks. And on the upper, it's asking you for incisive papilla, and it's also asking you for some tuberosities. And one last thing it asks you for is the position of your canines. Well, if you haven't done model analysis, you might get a little bit confused by that point. But if you have, you know that the canine positions are generally going to be at the position of your first major pair of palatal rugae. All of this stuff kind of been introduced, at least I've learned it, from the research done by the Professor Gerber. On the lower, we're looking pretty much at the same thing. If you're looking at the retromolar pads, it's asking you for the center, the buccal, and the lingual region. It's also asking you for canine points and the central ridge. Okay? If we go forward, let me go one slide forward. Excuse me. Here we go. So these are just regular models. I still do, and probably will for a long time, do quite a bit of analog work. But the same model analysis works surprisingly for both analog and digital. But what I wanted to show you is you see these three lines right here. The red stands for static line, the blue for outer correction, and the green for inner correction. What it basically does, it utilizes those anatomical landmarks to create this triangle. And within the confines of this triangle, the red is the ideal position of your central fossa. The green is the inner correction, is how far in you can move it, and the blue is how far out you can move it. What this allows you to do is it allows you to try to eliminate crossbite as much as possible without losing any function or possibly aesthetics of the dentures. Okay. If you look right here, this is a little bit different. You see where the ridge is, and you see where the retromolar pad is. Sometimes due to certain things, maybe some changes in anatomy or the impression wasn't done correctly, things are going to be out of alignment. You need to understand that. So just because you kind of have those confines that you're working within, well, those don't always work out. You have to use common sense. If we're going to draw the lines through here and here, well, our teeth are going to be all the way over on the tongue, and that's not going to work. So when you're utilizing model analysis, you still need to understand how the dentures are being set up and everything else. Okay, so once you do the model analysis, the software kind of presents the ideal setup according to the software. And you kind of have to look at things and see what needs to be done. Because the software won't automatically utilize the stop lines, and it won't automatically utilize the position of the teeth. So if you look, a lot of times you're going to have to remove some teeth in order to get things aligned in place. Also, you need to understand how the curves of Spee and curve of Wilson work, because you're going to have to go through all those movements to see if everything's balancing out correctly. Sometimes you want to be increasing that curve of Spee, especially if you're working with overbites and overjets. You know, that all kind of comes into play when you talk about Hanau's quint. You know, everything kind of works in balance. Okay. And here you can see those same lines on this model. You see the green line for inner correction, the blue for outer correction, and red for ideal. And within those confines, you can take your teeth and move in one way or the other, especially when you're dealing, let's say, for example, you're dealing with a class 2 or class 3 situation. The software, especially 3Shape at this point, it kind of presents everything in class 1 ideal, and you're going to have to go from there and just adjust those things. And as you can see right here, what I've done is I've actually taken out one of the bicuspids. You can see a little bit better right here, just so I have all the proper areas, because if I didn't do this, I would have lower teeth set up all the way up on the retromolar pads. And if you know something about model analysis, you know you don't want to set up those teeth too far back, otherwise it's going to destabilize the denture. So instead of just having vertical forces, you're going to have vertical and horizontal, causing the denture to lift up in the front. So by utilizing those things with model analysis, you're able to get really good functional dentures. As you can see right here, this was marks that I got once I started working with the articulator, virtual articulator, to see what marks I have on protrusion and lateral intrusion. Am I balancing everything? I generally look for group functions, and I'm looking for protrusive tripodization to make sure the denture is nice and stable. Once everything is done, you can actually go ahead, print or mill the dentures, which I'll show in a later slide. But what I wanted to show you guys is something like this. This is a setup also with VITA teeth. I'm using VITA pen XLs and linguiform posteriors. The reason I'm showing you this, these are pretty much the same tooth, except this is the analog version of this. Well, these are the version of the tooth that can be used with analog, and the ones that are going to be on the next slide are the ones that are going to be used with digital. The reason I want to show you this, guys, is that balance is very important, specifically when you're dealing with a restoration that's implant supported and retained, because the patient doesn't have the proper proprioception and they don't know what's going on. So if everything is not balancing just right, you can cause some real issues. So I can balance everything up in analog, making sure that the teeth are kind of gliding normally. I have certain balancing and working and balancing areas. And the same thing when you go with digital. So in this case, this is a Vigo denture, as I call it. So you have those Vigo teeth, which are pretty much the same linguiform teeth on the posteriors, and anteriors are similar molds to XLs and VITA Pen Plus. But this base plate, this particular one, is actually printed, but you can have a milled as well, and the teeth are actually going to be bonded into these sockets to look something like this. So just by utilizing certain aspects of model analysis and getting things positioned right, you're able to create a very nice and smooth and as well as an aesthetic restoration that is going to hopefully work for the patient for years to come. Okay, hopefully you guys enjoyed this as much as I did, and see you soon. Bye.